The standard table of normal distribution values is limited to positive z-scores, which means we can only use it if we have a probability greater than 0.5. It's also restricted to the cumulative distribution function, so we can only use it for less than or equal to probabilities. So what if we need to find a probability that's, say, 0.1, or for an event that's a greater than event? If we need that, we'll need to find a relevant probability. The hardest way to do that is to follow a bunch of rules. Instead, we'll draw a picture. For example, let's try to find the z-score where the probability x is greater than z is 0.8, where x has a standard normal distribution. So an important idea is that the probability is the area. Since our probability is 0.8, we'll need to find a region under the normal distribution curve with area equal to 0.8. And since our event is x greater than z, it will be the region to the right of some z-score. So the other important thing to keep in mind is the area to the left or right of the mean is 0.5. And since the probability we want is greater than 0.5, then our region has to include the mean. Now, the expression we use for the relevant z-score is not important, but since the relevant z-score is going to be negative, we'll designate it as negative z prime, and we note that the probability that we want is going to be the probability that x is greater than this negative z prime. But by symmetry, that's the same as the probability that x is less than the positive z prime. And we know the probability we want. And so now we have something we could look up on the table because this is a probability that's less than some amount. So searching the table, we find z prime is 0.84. And since we've drawn a figure, let's go ahead and label it with the appropriate values. And so that means that negative z prime, the z-score we want, is negative 0.84. Or let's find a probability x greater than or equal to z of 0.05. So it's important to remember the intern is planning on taking the actuarial exam, but you should actually draw the picture. And again, the probability is the area. We want to find a region with probability 0.5. Since our event is a greater than or equal to event, this will be the area to the right of some z-score. And again, the region to the left or right of the mean is 0.5. And since the probability we're looking at is less than 0.5, then the z-score we're looking for must be positive. So our probability is complementary to the less than probability. And we know our probability is 0.05, and so our cumulative probability is 0.95. And so consulting our table, we find z is approximately 1.64. Which means the probability to the right is 0.05, which is what we want. Or we could try to find a probability like this. So again, one of the advantages to drawing the picture is that the algebra is optional. We don't have to introduce notation for the actual z value. So here we want to find a region with an area of 0.1. And since our event is a less than or equal to event, this will be the area to the left of some value. Again, in the normal distribution, half the values are going to be below the mean. So our desired z-value must be someplace over here less than the mean. This means there's a corresponding value above the mean with the same area, where the area to the left is 0.9. Searching our table gives us z approximately 1.28. This means the area to the left is 0.9, so the area to the right is 0.1, and by symmetry, the area to the left of negative 1.28 is also going to be 0.1. Which means the z-score that we want is going to be negative 1.28.